to study ways of improving public transportation. How many committees could be formed from the 8 people on the Board of Supervisors?
Alright, so what lets us know that this is a combination?
How many combinations?
No.
The
order doesn't matter, right? The 3-person committee that's needed, do the 3 people have to be in any certain order? No, one's not higher than one of them, right? They're all on the same committee. They all have the same job. So it is a combination problem. And we are going to use this formula because it's talking about combinations of n taking r at a time. Go ahead and make an arrow. Just to remember that n is the bigger number, always, and r is the smaller number, always. So in our example for number 1, which one's going to be n? 8, because 8's the bigger number, so n equals 8. And r would be what? And so now we'll just set up our formula. So this would be 8c3 equals what on top? 8 what? Factorial. Times. Good. So I'm just following this formula right here. Alright, let's go ahead and simplify what's in the parentheses. So this will be 8 factorial over what? 5 factorial, 3 factorial. Alright, on top we'll have 8, 7, 6, 5, 4, 3, 2, 1. And on bottom, let's put these in parentheses. So the first one will be 5, 4, 3, 2, 1.
Well, do we have necessarily
3, 2, 1.
if we already know it's going to cancel out?
No, you don't have to. You can do shortcuts if you want. So like Mackie said, which one do we want to cancel out on bottom? The bigger factorial, which is going to be what? 5. And so on top we'll have 8 times 7 times 6. What's that going to be? 336 on top. And 6 on bottom. So what's 336 divided by 6?
56.
Very good. Any questions about that one?
Are you going to have the formula on that?
I am. Everybody's good with that one? You can also do this in your calculator, and I figured out ways to do it in like just about every calculator. So after class I'll come around, and if you want to know, I'll show you how to do it on your calculator. Like for example, let's see if this one. Yeah, this one does it. Does anybody have a TI-30XS? Okay, I'll show you how to do it on this one. So go ahead and type in 8 first, because that's the number out front. And then type this PRB thing and see where it says NCR. Go down to NCR and then type 3. Everybody, do I need to do that one more time?
Yeah.
Okay. So clear it, type in 8, and then this PRB is where you're going to find your permutations, combinations, and factorials. So go to NCR, enter, and then 3. Enter. Alright, so again, if you need some help with your calculator, I'll show you at the end of class. Alright. Georgia, if you'll read number 2 for me.
Volunteer pet sit for your friends. You have 7 different animals. How many different pet combinations are possible if you take 3 of the 7?
Alright, so again, order does not matter, correct? It doesn't matter what order you take the pets in. So this is a combination problem. We're going to use the same formula. What is our N?
7.
And our R?
3.
Good. So we'll have 7C3 equals what on top?
7.
7. Good. Over 7 minus 3 factorial, 3 factorial. So on top we'll have 7, 6, 5, 4, 3, 2, 1. Alright, this will cancel to 4 factorial, correct? So 4 times 3 times 2 times 1 times 3 times 2 times 1. Which factorial should we cancel out? 4.
210 over 6. 35.
So on top we'll get what now? 210 on bottom? So our final answer? Very good. If you have like your calculator and it does it for you, you don't have to show work on your quiz. You can just use calculator.
It's pretty easy.
I'm glad you think so. Alright, any questions about this one? Alright, Levi, if you'll read number 3 for me.
How many different 4 cards?
That's 4.
Oh, excuse me. In poker, a person is dealt 5 cards from a standard 52 card deck. The order in which you are dealt the 5 cards does not matter. How many different 5-card poker hands are possible?
Alright. So what is our N in this one?
52.
52, because there's 52 cards in a deck. R would be 5. So this is 52 C5. I'm going to let y'all do this one and number 4 on your own. And then I'll call on one person for each answer.
Well, this one's getting these no worries.
Oh my god.
Any calculator?
Yeah, you see like
52. Now. All the way over to PRB. Here it says NCR. And then you have any other number.
well, that's
This
pretty
one.
awesome.
Anybody need help with their calculator?
I'm actually
Yeah, it's gonna be really big. It's 50% to be
yeah, that's right.
Nothing.
Shift. This and then your yes. Yeah, alright, 5 times 52. And see that PRB, go all the way over to NCRN, and then your other number.
That's actually.
Yeah. Anybody else want to see it in their calculator? Okay. Hold on 1 second. Alright, so 52, hit the PRB button, and see where it says NC, go over to that. Enter. And then hit this 5 button right here, because that's your first number. Enter. So we go over there. Yep.
I'm like, a lot of people used to put them on my fingers.
Alright, let's go over these together. It's the PRB button, but it's not on your phone.
What's this for? It's supposed to be a big number like this. That's it.
Alright, one person. Jarius, if you'll tell me what you got.
19 still.
Good. Did everybody get this? Okay. So that's how many you could have 2,589,960 different poker hands.
That's a line. 1,800.
That's the different combinations.
I got the same thing, but I did the commas wrong.
Alright. Any questions about this one? Yes, Taylor.
Okay, right. Instead of like writing out and put it on calculator, do it matter if you know if it's combinations or
Yes. You notice how when you go in your calculator, there's a P and a C. There's 2 different ones. Permutation's the P button. Combination's the C button. So it's very important that you type which one, because it'll give you different answers. Do you want to do the next one, Austin? Go ahead.
I got 1,820.
You mean 1,820? Okay.
I got it. Dang, deal.
So how many different 4-card hands can be dealt from a deck that has only 16 cards? That's going to be 1,820 different ways. Any questions? Okay, what we're going to do now is the back of this. You're not going to be working this on your own. We're going to work this together, and then you'll be working some on your own. So scratch out this homework thing. I've decided we're going to work these together, and then we're going to, you're going to work some on your own at the end of class. Alright, go ahead and do 1 through 3 in your calculator if you have it. If not, just work it out by hand. Okay, we're using the same formula, just different numbers. So just stop after you get done with number 3, and I'll call them 3 people in just a second.
So it would be like 12
Mhm.
C's.
I want you. Remember that. Let me open up your
Anybody need more time?
Me. Wait, did we do 14?
No.
We're not supposed to do them before?
No.
Oh, okay. I got it.
Alright. Alexis, what'd you get for number 1? Raise your hand if you agree. Raise your hand if you disagree. Good. That is correct. Any questions? Alright, Eric, what'd you get for number 2?
2002.
Raise your hand if you agree. Anybody disagree? Okay, good. Questions? Alright, Heidi, what'd you get for number 3?
28.
Everybody agree?
Yeah.
Good. Alright, so everybody's good with those. Now the next 3 are going to be what you're kind of going to be doing on your own, so make sure you're paying attention. We are going to have to determine whether it's a permutation or combination, and then we're going to have to solve. Okay? So,
Permutation.
for number 4, Brittany, if you'll read that one for me.
In a race in which 6 automobiles are entered and there are no ties, in how many ways can the first 3 finishers come in?
Alright, what do we think? Why?
Because you can only one person can be in first.
Yeah, order does matter when it's a race, right? We have first place, second place, third place, and so on. In other words, like she said, 2 people, a person can't come in first and second, right? Also, 2 people can't come in first place, correct? So order does matter, so this is permutation. And now look in your, if you can't remember, look in your 11.1 through 11.2 notes and tell me what was the formula for a permutation. And this is giving you 2 numbers so we know it's in objects or at a time. Anybody remember that one? The formula for a permutation. Go ahead.
You just multiplied the 6 and 5.
No. No, sir. Go ahead.
Once you put 6 over 3, right?
That's if we're doing with repetition.
Is it n factorial over parentheses n minus r?
That is it. This is the formula. This is for permutations taken in objects R at a time. So if it gives you two numbers like this, where it's 3 and 6, hold on. And nothing's repeating, right? There's no repetition in this one. So it's not like the ones where we count how many letters are repeating. It's not like that. This is the formula that you'll use. Okay? So what is our n in this one?
3.
6.
Oh, let me see.
What is r?
3.
So we have 6 factorial over 6 minus 3 factorial.
Which equals 3.
So this is 6 times 5 times 4 times 3 times 2 times 1 over what?
3 times 2 times 1.
So these cancel out. And that makes what?
120.
6, 5, 4.
120.
Yes. You said what?
I said the 6 times 5 times 4, and you're like, no.
I thought you were talking about just finding the factorials of each one. Okay. Very good. And you could have typed this in your calculator how? Using what button?
The NPR.
Good. 6p3.
Oh, we can use it for NPR?
Yeah. Instead of the C button, you'll use the P button because it's a permutation. All right. Next one, Justin, if you'll read number 5.
A book club offers a choice of 8 books from a list of 40. In how many ways can a member make a selection?
All right, permutation or combination? Good. Order doesn't matter, right? Tell me the formula we'll use. Somebody.
NCR
All right, NCR equals.
equals N, square, exclamation point, whatever, and the parentheses, N minus R. R parentheses, R exclamation point.
Good.
Whoa.
So this is combination and it's taking n objects R at a time. What is our n in this one?
8.
And our R?
Oh,
8.
okay. I'm at R.
So you can either type in 40C8 in your calculator, or I can write out all of the list of 40 factorial.
Is it going to be a big number?
I'll give you time to calculate it first, then I'll call on somebody.
76 million. My bad.
All right, now go ahead.
76,904,685.
That is correct. All right, questions?
Nope.
All right. Caitlin, if you'll read that last one for me.
9 colony acts will perform over 2 evenings. 5 of the acts will perform on the first evening. How many ways can the schedule include the first evening?
All right, this one's tricky. What do we think?
Permutation.
All right, Guy, why would you say that?
Because, like, you have to get rid of some because they're already the first evening. You gotta use those for the second evening.
Good. So the 5 that perform on the first evening, will they perform on the second evening?
No.
So order matters, right?
Yeah.
Okay. So it can't be repeating. So this is a permutation. And what formula would I use?
9P4.
9p4. Good. What's the formula?
N factorial.
Good.
N minus R.
Perfect. I'm going to write this one out. So this will be 9 times 8, 765, 4321. Over, and then n minus r, so 9 minus 4 would be what? So we would really calculate what? 9 times 8 times 7, which gives us what?
2,724.
I got 504.
I got 504.
Let me check. Yes.
Oops.
We forgot the 6.
Yeah, so I was right.
So what is it?
3,724.
Say it again.
3,724.
Good. We forgot the 6. We only canceled out the 5.
You made it look.
It's my fault.
Wash your crosses.
Alright, any questions about telling the difference? Because y'all about to do some on your own. Alright, this is how we can do this. We can either work on your own, and it's 15 problems. You can either work on your own and turn this in at the end of class for a grade, or we can play the X game with the whiteboards, but you won't get a grade for it. So raise your hand if you want to do it by yourself for a grade. Raise your hand for the X game.
I need a high grade.
Can we finish it Friday?
Raise your hand, man.
You
Alright.
want to finish it today?
No, has to be done today. So I'll say this one more time. Raise your hand if you're going to do it in class for grade. 1, 2, 3, 4, 5, 6, 7. Alright, raise your hand for X game. Y'all can't vote twice.
I didn't vote twice.
Alright, we'll play the X game. Alright, go ahead and get out your whiteboard.
What if we don't want to play this game? Can we do it?
That's too bad.
No, you have to play the X game. Everybody does one thing, everybody does the other. Whoever wins this can get 5 points on their quiz tomorrow.
I need to get grade.
Miss Martin, you can make your backyard.
Gotcha.
Wouldn't it be what now, White?
It would be extra or
How's football?
Yeah.
That's not your phone first.
How's football?
Hard.
Say that again?
It would be 5 instead of 4, wouldn't it?
Yes. Why did we put 4? I don't know. Yes, it'd be 5.
Yeah, don't worry.
Are you tomorrow?
Yeah.
Okay.